There's something almost poetic about watching raw steel transform into precision machinery. Today we're inside Cymex Engineering, where they're forging the heart of their CBE crusher bucket, a massive shaft that'll spend its life doing the tough work most of us never see. Now, if you've ever worked a construction site, you know crusher buckets are game changers. They attach right to an excavator and pulverize concrete and rock on the spot. No hauling debris across town. But here's the thing. That shaft spinning inside takes a beating like you wouldn't believe. That's why Cymex starts with forging. They heat the steel white hot and hammer it into shape, aligning those metal grains for maximum strength. It's old-school metallurgy meeting modern needs. After forging, the shaft moves to CNC machines for cold machining, computer-controlled precision that shaves it down to exact tolerances, sometimes within thousandths of an inch. This two-step dance, forging for toughness, then CNC for accuracy, creates a shaft that laughs at torsional stress and shear forces while grinding through rubble day after day. There's something almost magical about watching precision machinery at work, and this robot head you're seeing here is a perfect example of modern manufacturing meeting old-school craftsmanship. This beauty is being machined by Sandvik Coromant, a name that's been synonymous with cutting tools since way back in 1942. What makes this special? Well, the cutting inserts and tools doing all this intricate work come straight from Sandvik's largest production facility in the world, located in Gimo, Sweden. Now, Gimo might be a small town, but it's been the beating heart of cutting tool innovation for decades. Imagine a place where they've been perfecting the art of metalworking since the 1940s. That's the kind of heritage we're talking about. The process you're watching involves multiple milling operations. First, the rough cuts remove bulk material quickly, then comes the semi-finishing to establish proper geometry, and finally, those precision finishing passes that create the smooth surfaces you see. The robot head requires extremely tight tolerances. We're talking about measurements so precise they're smaller than a human hair. These cutting inserts aren't just sharp pieces of metal. They're engineered with specific geometries and coatings that can withstand tremendous heat and pressure. Some can handle temperatures over 1,800 degrees Fahrenheit while maintaining their edge. It's this combination of Swedish engineering expertise and cutting-edge technology that allows machines to create components that would have seemed impossible just a generation ago. Now here's a sight that really takes me back. Watching Caterpillar equipment being built. I remember when Cat first started making smaller machines back in the 70s. Folks thought they were crazy, but boy did that gamble pay off. What you're seeing here is Caterpillar's Athens, Georgia facility, and let me tell you, this place is something special. This plant has been building compact equipment since 1999, and it's become famous throughout the industry for how they've blended traditional manufacturing values with cutting-edge automation. The process starts with heavy steel plates and fabricated frames. Watch how those automated welding robots move. They're performing hundreds of precise welds per machine, each one consistent and strong. The assembly line you're watching uses what they call intelligent assembly systems. Sensors and cameras guide workers and robots alike, ensuring every bolt gets torqued to the exact specification. Every hydraulic line is routed perfectly. It's like having a master mechanic's knowledge built right into the production line. These mini excavators and compact dozers might be smaller than their big brothers, but they're built to the same rugged standards. Caterpillar knows these machines will be working in tough conditions, digging through Georgia red clay, pushing snow in Montana winters, trenching in the Texas heat. That's why even though they're made with modern technology, they're still designed with that same durability Cat's been known for since Benjamin Holt built his first tractor back in 1904. The Athens plant takes special pride in ensuring each machine can handle punishment. Every hydraulic cylinder gets tested, every engine run-in is monitored, and the final inspection is thorough enough to make your grandfather's quality control look lenient. It's this combination of automated precision and hands-on craftsmanship that makes these compact machines reliable partners for contractors and homeowners alike. Here's where metalworking gets really interesting. Watch this sheet metal transform into a perfect cone shape. This is Occupac's AHS series plate bending machine, and what you're witnessing is a clever bit of engineering that solves a tricky problem. Bending a cylinder is straightforward. All 3 rollers move evenly, but a cone? That requires different diameters at each end. The AHS series uses something called a conical bending device. Think of it like this. While one end of the metal sheet moves normally through the rollers, the other end is partially restrained, creating that gradual taper. The operator can precisely control the angle by adjusting how much one end is held back versus the other. It's like rolling dough, but with one hand pressing harder than the other. This Turkish company, Occupac, has been perfecting this technology since the 1980s, and watching it work is like seeing geometry come to life in real time. Now, this is something you don't see every day, and it connects us to a tradition that goes back centuries. What you're watching is the creation of a 4-strand tarred manila rope made from sisal, what we call gai dao in Vietnam. And this particular rope has a very special purpose. This rope is being crafted for the rigging system of the Guren, a historic vessel in Hardanger, Norway. When I see this process, I'm reminded that some technologies, some crafts, they don't need replacing. They just need respecting and preserving. The process starts with sisal fibers. Now, sisal comes from the agave plant and has been the rope maker's friend since the late 1800s. It's strong, durable, and when treated properly, can last for decades. The fibers are first cleaned and combed, straightening them out so they'll twist together evenly. Watch how those strands are being twisted. This isn't random. It's being done with just the right amount of tension and at a specific angle. Too loose, and the rope won't hold under load. Too tight, and it becomes stiff and difficult to work with. Rope makers used to learn this by feel, passing the knowledge down through generations. Now comes the tar treatment, and this is where it gets really traditional. The tar, usually pine tar or coal tar, serves multiple purposes. It waterproofs the fibers, prevents rot, and makes the rope more resistant to the harsh marine environment. When this rope is mounted on the Guren's masts, it'll face rain, salt spray, and the harsh Norwegian weather. That tar coating is its armor. The 4-strand configuration you're seeing is interesting because it's actually less common than 3-strand rope. 4-strand is more symmetrical and tends to be more resistant to rotation under load, which is crucial for sailing vessels where the rigging needs to be absolutely reliable. Each strand is twisted in one direction, what's called the yarn twist, and then the 4 strands are twisted together in the opposite direction. This counter-twisting is what gives rope its strength. Try to pull the rope apart, and those opposing twists actually grip tighter. For a historic vessel like the Guren, using authentic rope-making methods isn't just about appearance, it's about preservation. Modern synthetic ropes might be stronger, but they wouldn't be true to the ship's heritage. This rope, made the traditional way, helps keep history alive while still being functional enough for the vessel's operation. Here's a neat piece of technology that solves an age-old machining problem. Watch this face chuck in action. This is FRB Technologies' face gripping system mounted on a Mazak QuickTurn Nexus 250 IIM lathe, and it's pretty clever when you understand what it's doing. Traditional lathe chucks grip the outside diameter of your workpiece. That works fine, but here's the problem. Those jaws stick out, which means your cutting tool can't machine the full length of the part in one setup. You'd have to flip the part around, re-chuck it, and hope everything lines up perfectly. The FRB Face Chuck changes the game. Instead of grabbing the outside, it uses teeth that bite directly into the face, the flat end of your workpiece. Think of it like holding a coin by pinching its face rather than gripping its edge. Why does this matter? Because now the entire outer surface is completely accessible. Your tool can travel the full length without hitting the chuck. That means one setup, better accuracy, and faster production. For parts like shafts, pins, or hydraulic components, this is a game changer.